Let's take a look at our Algebra Honor Study Guide for Unit 6 on radicals and exponents. So, we're just going to dive right in, but remember you should work through these problems first and then check to see if you got the right answer, and if you did not, maybe follow along with the video. Also, remember there are lots of ways to solve each one of these problems, so if you have approached the problem differently, that doesn't make it wrong. So, okay, we're going to say xy cubed, all in parentheses, squared. I'm going to distribute that outer exponent to each of the factors inside. So remember, this x has an invisible exponent of 1. When we distribute that outer exponent, we're going to multiply exponents together. So I have x to the 1 times 2, which is x squared, times y to the 3 times 2, which is y to the 6. Okay, number 2 over here, I am going to simplify. So 5 is going to stay in the numerator because I don't have anything, just plain numbers in the denominator. I have x to the 10 over x to the 15th. So the way I'm going to do this problem is I'm going to say 15 minus 10 is 5. So I'm going to have x to the 5th left over after that division, and I'm going to keep my answer wherever the bigger exponent was. So 15 minus 10 is 5, and I stay where the bigger exponent was. Y to the negative 3, I need to move that up so that I have a positive exponent. So I'm going to have 5y to the 3rd over x to the 5th. All right, remember that with number 3 here, we have 5 times n to the 3rd times all of this. So I need to distribute this outer exponent first. But also remember that if I had just negative 1 squared in parentheses, if negative 1 is in parentheses and I square it, then it's going to become positive. So I'm going to rewrite this so that you can see what I'm saying. We just have 5n to the 3rd times, if you imagine this is negative 1 times n to the 4th inside those parentheses. Okay, so you know if I just had negative 1 in parentheses squared, it would be positive 1. And then, of course, I have n to the 4th squared, so I'm going to distribute this outer exponent, but I'm going to imagine that that negative 1 is in parentheses. Okay, so I'm rewriting again, 5n to the 3rd times negative 1 squared times n to the 4th squared, which is going to be n to the 8th. So I have distributed that outer exponent to the positive 1 exponent on my negative 1 there, and also to the positive 4 exponent. Okay, negative 1 times negative 1 is positive 1. So I have 5n cubed times n to the 8th, which I know is 5n to the 11th as my answer. Okay, number 4, I'm going to, well, I think I'm going to move my things that have negative exponents into new locations so that I have positive exponents. I'm also going to simplify. 4/16 we know is the same as 1/4. Okay, so I'm going to rewrite this now that I have simplified my numbers, and I'm also going to make my exponents be positive. Oh no, you know what? I'm not. Hang on 1 second. Anything divided by itself is 1, so I'm going to say m divided by m is just 1. All right, so now what I have left is, in the numerator, 2p to the negative 2. I'm going to move that to the denominator so that it becomes 2p to the positive 2. Okay, that's taken care of. I still have 4 in my denominator, right? So that's taken care of. P to the negative 4 was in the denominator, and so we're going to move it up to the numerator, and so now it's p to the 4th. Okay, I've taken care of all of the factors, and now I get to simplify. I need to distribute that outer 2. Don't make your big numbers sad when they're inside the parentheses. We have to distribute that 2 to everything inside. So I continue to have p to the 4th in the numerator, and now I have 2 squared, which is 4 times p squared times 4, all in the denominator, right? P to the 4th over p squared is going to be p squared, and 4 times 4 is 16. So I p to the 4th over p squared, I took care of those, and 4 times 4 is 16, I took care of those. That's my answer right there. All right, make sure you're trying these on your own and then checking them. Okay, so let's look at number 5. We're going to simplify. We have negative 20 over 5. So negative 20 divided by 5 is going to be negative 4. I have y squared, so I've taken care of negative 20 and 5. I'll just mark those out. Y squared over y to the 5th, I'm going to say that is y to the 3rd in the denominator. 5 minus 2 is 3, and I'm going to stay in that denominator. Okay, z cubed over z to the 1, that's going to be z to the 3 minus 1, which is z squared. Number 6, first of all, anything to the power 0 is 1, so that's 1. I'm going to go ahead and just distribute this negative exponent, and then I will move things. You could put that whole expression into the denominator first if you want to. I'm going to go ahead and distribute so that now I have 5 to the negative 2, x to the negative 8, y to the 4th, right? Negative 2 times 1 is negative 2, negative 2 times 4 is negative 8, and negative 2 times negative 2 is positive 4. So that's going to be y to the 4th over 5 squared, which is 25, x to the 8th. Okay, this becomes 5 squared because I moved it to the denominator. And then, of course, I know 5 squared is 25. X to the negative 8, when I move it to the denominator, becomes x to the negative 8. Okay, I'm going to have to distribute some outer exponents 2 different times. Again, you are going to remember that this negative 2 is inside parentheses when we give it its exponent. Okay, so I have negative 2 to the 4th times x to the 2 times 4, which is 8, times y to the 3 times 4, y to the 3 times 4 is y to the 12th. It's all times negative 1 to the negative 2, right? This is a negative 1 to the negative 2 times x to the negative 2. I have distributed that negative 2 to the elements inside. All right, negative 2 to the 4th is positive 16, and I have x to the 8th, y to the 12th, and this is going to be over, I'm going to go ahead and do this in multiple steps here, negative 1 squared, even though we know that's just going to be positive 1, and it's also over x squared. I had to move these two down because of the negative exponents. Okay, so I have 16 divided by 1, so it's just 16. X to the 8th over x squared is x to the 8 minus 2, so it's x to the 6. Y to the 12th is my answer. All right, if we have a fraction inside of parentheses and we are raising it to some power, you can simplify your fraction first if you want to. Or you could distribute this outer exponent to every single factor that's inside. I'm going to simplify first. That is, I think, what I typically do. So this is going to be inside the parentheses. 2 over 4, of course, becomes 1 over 2, right? So I'm going to have 2 in the denominator. I'm going to go ahead and move my negative exponent, guys. Okay, so I moved x to the negative 3 up, and I moved x to the negative 2 down. Okay, so all I did was I simplified inside my parentheses. I'm going to continue to simplify inside my parentheses, so I have x over 2, and it's all raised to the 3rd power, so x cubed over x squared is x, right? So now, if I distribute, I have x to the 3rd over 2 to the 3rd, which is really x to the 3rd over 8. Okay. Here's hoping I haven't made any careless errors. All right, so for these problems, you want to make sure that you understand how to find an error. If you're putting your answers into our Go Formative program or platform, you can just put the correct answer, what it should have been. So if I say find the error, I'm implying that something is wrong and this is not the real answer. So here, again, I know this is negative 1 times x all squared. And so I need to remember that that negative 1 is going to be squared. It's going to become positive. I can see that's what the problem is already. It's times x to the 4th. So once I distribute that outer exponent, I should just have x squared times x to the 4th, which is going to be positive x to the 6th. The error is that that negative that was inside the parentheses did not get squared. Over here, let's see what our error is. Oh, I can see it right away as well. When I distribute that outer exponent, I need to distribute it to absolutely everybody. If I'm asked to do a find the error problem, I usually look at the problem and try to solve it myself first and see what answer I get, and then look and see what went wrong with the answer that we know is incorrect. So that's just my personal approach. All right, so I know I would have gotten 2 to the 4th, x to the 8th, all over y to the 3 times 4 is 12. And I can see that they forgot to distribute that outer exponent to the 2 there. Okay, 2 to the 4th, of course, is 16. So my answer would have been 16 x to the 8th over y to the 12th. That is the correct answer. Okay. Simplify the following radicals. Make sure when you're doing these that you are looking to see whether you're finding square root or cube root. Okay. Also remember all of your rules about radicals. We can't leave anything under the radical that is a perfect square or a perfect cube or whatever our index is. We need to make sure there are no factors that could be rooted out, shall we say. Also, we can't have a fraction under the radical bar, and we cannot have a radical in the denominator. So one more reminder, if you're doing cube roots, you can't have a negative left over inside the radical. You have to take that out. All right, so this is square root, so I'm looking for perfect squares, and I can see some already. I'm just going to rewrite this so I can see all of my perfect squares. 81 is a perfect square. X squared is a perfect square, because any even exponent is a perfect square, right? And then I'm going to make this next guy y to the 4th times y, because y to the 4th times y to the 1, it really is y to the 5th. I broke that up so that I can see my perfect squares, and now I'm going to take the square roots of my perfect squares. Square root of 81 is 9, square root of x squared is x, square root of y to the 4th is going to be y to the 4 divided by 2, so y squared. And I couldn't do anything with that y, so it is still needing us to take the square root of it. Okay, on this one, I can break this up if I need to make it look like 64x to the 10th over the square root of y squared. Be careful and remember that when you are breaking up a fraction that's under the radical, that you are still taking the square root or the cube root or whatever of the numerator and the denominator. Just don't lose that square root. All right, so I know the square root of 64 is 8. The square root of x to the 10th is x to the 5th, because 10 divided by 2 is 5. And the square root of y to the 2nd is y, right? Square root undoes squared. That's my answer there. Square root of 98, I need to figure out what factors I have in there. So I happen to know that that's 2 times 49. So that equals the square root of 2 times 49. I see my perfect square. That's 7 times the square root of 2. Okay, if you didn't remember that, you can break 98 into its factors. 2 times 49. Say you didn't even notice that 49 is a perfect square. Once you break that down into its factors, if you're looking for square root, you're looking for pairs of numbers to pull out. And there's my pair. I have a pair of 7s. So the square root of 7 times 7 is just 7. That's how I know what to pull out. All right, number 4. I have a couple different ways that I can do this. I am going to pull that negative 3 out. So it's negative 3 times the next thing I'm going to do. I'm going to put the square root of 32 over 36 all in one house. Okay, and then I can simplify. So that's negative 3 times the square root of, let's put 4 into each of those, 8/9. Okay, I have negative 3 times the square root of 8 over the square root of 9, which is negative 3 times the square root of 8 all over 3, which is, of course, just negative square root of 8. Okay, that is my answer, negative square root of 8. You also could have done this separately. Okay, so you could have said that this is negative 3 times the square root of 16 times 2 over 6. There's no worries about which way you're choosing to do this. I would say that's negative 12 times the square root of 2 over 6. And I'm so glad I did this the second way, because guess who didn't simplify all the way? Me. Okay, so when I do negative 12 times the square root of 2 over 6, I get negative 2 times the square root of 2. But wait, you say, negative 2 times the square root of 2. You told me it was negative square root of 8. Well, I did, because I totally didn't simplify all the way. Look, negative square root of 8, we know that's the negative of the square root of 4 times 2. This equals negative 2 times the square root of 2 if you simplify it all the way. No Jolly Ranchers for you guys, because I caught my own mistake. Thank goodness. Okay, there are, as always, several different ways to do all of these problems. Okay, 2 times the square root of 72, x to the 8th times y, all of that is the radicand, excuse me, under the radical. So I'm going to say that's 2 times the square root of, let's see, is 36 times 2, 72? I think so. Times x to the 8th times y. So looking for perfect squares, I see them. I'm going to say this is 2 times 6 times x to the 4th, again 8 divided by 2 is 4, times the square root of whatever was left in there, so 2y. 2 times 6 is 12, I get 12x to the 4th times the square root of 2y. And over here, number 6. Okay, square root of 36x to the 4th over 121y to the 10th. I can see that's a whole bunch of lovely perfect squares. So I'm just going to rewrite it, although it's up to you how much you rewrite. I'm doing it so you can see my thinking. So perfect squares in here, I have 6x squared. Perfect squares in here, I have 11y to the 5th, and I'm pretty sure that's what we get there. All right. Okay, so we're working through this. I have 1/5 times the square root of 50, and I know there's a perfect square inside that square root of 50. That's going to be 1/5 times the square root of 25 times 2, which is 1/5 times 5 times the square root of 2. And of course, 1/5 times 5 is 5/5, which is just 1. So my final answer here is square root of 2. 8, I have 160 over 8. That would be 16 times 10. I think I'm going to try that. So I have the square root of 16 times 10 all over 8. So I have 4 roots of 10 over 8, and I need to simplify because I don't want my math teacher to do any work. So square root of 10 over 2, right? 4 goes into 4 one time, and 4 goes into 8 2 times. Incidentally, that is also the same thing as 1/2 times the square root of 10, but it's fine to leave it as a fraction like that. Okay, here I have negative square root of 3 times 5 times the square root of 12. This is really -1, right? So we're going to multiply -1 times 5 and get -5. And then we're going to multiply the square root of 3 times the square root of 12, right? Because as long as it's the same index, I can multiply them together using the product rule. So -5 times the square root of 36 equals -5 times 6 equals -30. Number 10, hopefully you looked at that and you said, haha, that's a perfect cube, which means that this is the cube root of 5 cubed, and a cube root undoes a cube, and so our answer is 5. If you didn't, though, just start dividing up 125, right? So I know 5 goes into it, it ends in 5. 5 goes into 12 2 times, 25 5 times. And I can see 5 goes into 25, and now I have a triplet. So that's what I would take out. Okay, first thing I'm going to do if I have a negative radicand is pull that negative out. So this is going to equal negative of the cube root of 54. But I also know 54 is 27 times 2. Okay, so most of the time if we give you a number that is under the radical, if we give you a number under a cube root, it's either going to be a perfect cube like 125, or it's going to be a multiple of something that's a perfect cube. Okay, that's just a hint on a lot of these problems. So I know 27 is a perfect cube. It's 3 cubed, right? So I have negative on the outside, and I'm going to say that now the cube root of 27 is 3, so I'm pulling that 3 out. And I still have to leave the cube root of 2 inside. So my answer is -3 times the cube root of 2. I don't know why that looks so messy. Sorry. It still looks messy. Okay, 12. 1024. Well, I am trying to think about this. I feel like if I divide that by 2, it's 512. I feel like 512 might be a perfect cube. So I'm going to put in 512 in my calculator, and I'm going to come down here. The cube root is above that 0. See the little numbers and whatever. So that's my second function above the 0. Hey, it is. 512 is the is 8 cubed. So I know that this equals the cube root of 8 cubed times 2. Guys, I literally took 1024 and I divided it by 2. That's how I got 512. So 2 times 512 is 1024. Okay, 8 cubed times 2 is 1024. All right, this equals 8 times the cube root of 2. 3 times the cube root of 500, x to the 7. If I'm looking for the cube roots of variables, I need exponents that have multiples of 3. Also, 500, I've got to think about what factors of 500 work for me. So I'm going to go out on a limb. I know 125 is a perfect cube. Remember, we just talked about that. I like numbers that end in 5 and numbers that end in 0. So 125 times 4 is 500. So here's what I'm going to do. I'm going to rewrite this. It is 3 times the cube root of 125 times 4. I chose that because I know 125 is a perfect cube. Okay, and I'm going to make my x's have exponents that are multiples of 3. 3 now because I want the cube root. So I'm going to say this is x to the 6th times x. Okay, so make sure you believe me that you feel like everything under the radical here equals what we started with. And now I'm going to start taking cube roots of perfect cubes. So I have 3 already on the outside. I'm going to say times 5 times x to the 6 divided by 3 is 2. I still have 4 and x under this radical, so it's times the cube root of 4x. 3 times 5 is 15, x squared times the cube root of 4x. That should be my answer. Okay, and 14, here we go. Cube root of, okay, so again, I want all of those exponents to be multiples of 3, so let's just rewrite it. So I have the cube root of x to the 3rd times x squared. Okay, that guy's done. Y squared I can't do anything with because I don't have enough y's. And then z to the 10th, I'm going to make that be z to the 9th times z. Okay. Now I'm taking my perfect cubes and I'm going to pull them out. Okay, so the cube root of x cubed is x. The cube root of z to the 9th is z to the 9 divided by 3, so it's z cubed. And then I still have all that stuff inside. So cube root of x squared, y squared times z. That's all under the radical still. All right, we are working on a lot of stuff. I'm going to try to get everything else done in this same video. Let's see how it goes. Okay. So it just says indicate your answer for each question. When both x and y are greater than 0, which expression is equivalent to this guy in simplest form? I'm going to go ahead and simplify this myself. And then I'm going to see, it looks like some of these are not simplified, right? Because square root of 8 we know is not simplified. So I'm going to have to kind of simplify everything. So here's our granddaddy of all that we need to be equal to. I know that's going to be 36 times 2 times x to the 8 times x times y to the 6. Okay, I'm just simplifying the original expression. So this is going to be 6 x to the 4th y to the 3rd, because 2 goes into 6 3 times, yeah. Okay, and then times the square root of 2x. This is what I need to ultimately be equal to. So let's look and see. 3x to the 3rd y squared, square root of 8. I don't think that's going to work because there's no x under that radical, but just in case, let's go ahead and simplify. 3x to the 3rd y squared times 2 times the square root of 2. right? Because that's 4 times 2, and the square root of 4 is 2. So this would be 6x to the third y squared times the square root of 2. Yeah. And that is close to what I've got, but it is not entirely what I've got because I'm missing an x, so it's just not a, plain and simple. Okay, this guy is going to be 3x to the fourth, y to the third. Again, I know the square root of 8 is really 2 roots of 2, yeah? So I'm going to say times 2 times the square root of 2x. Everybody okay with that? I took 8 apart and made it 4 times 2. Now if I simplify, I get 6x to the fourth, y to the third, because 3 times 2 is 6, times the square root of 2x. Let's compare 6x to the fourth, y to the third, times the square root. That works. So that is true. It does say which expression, singular, but I'm just going to double check and make sure I didn't do something silly. So I'm going to check these guys. That is as simple as it can be. Super close, but it's missing the x inside. And just for kicks, I'm going to check this guy. So I've already simplified my radical. 6x to the fourth, y to the third. 6x to the fourth, y to the third times the square root of 2x. Well, that sure looks like it works. So 6x to the fourth, y to the third times the square root of 2x. Huh. I'm just going to come back because it only asked for 1, so I'm going to come and check this guy again. So I have 3x to the fourth. I'm just redoing this to make sure I didn't mess something up. Y to the third times the square root of 4 times 2 times x. So it's 3. You can pull out that square root of 4 is 2 times x to the fourth, y to the third times the square root of 2x. It really is 6x to the fourth, y to the third times the square root of 2x. That, as far as I can see, means that both of those are correct. So there you have it. I would answer both of those on my study guide. All right, last page. Woo. So it says which value can be placed under this radical symbol to make the statement true. So I'm looking at 2 times the cube root of 5. So I can do this 2 different ways. I can plug each one of these guys under that radical and see if it's true. That's see if it is equivalent. The cube root of 10 is not 2 times the cube root of 5, right? That's not. Cube root of 30, let's see, cube root of 30, I can't simplify that, right? Because 30 doesn't have any cube factors, so it's not that. Cube root of 40, let's see. Cube root of 40, well, I know that's 8 times 5, so that's the cube root of 8 times 5, which is 2 times the cube root of 5. Ooh, that's what we want. Okay, and so the cube root of 50 I know is not going to work because 50 is 25 times 2 or 5 times 10. That's not going to work out. Okay, so one way is just to plug in all of those answers. The other way to do this is I know that if I have 2 times the cube root of 5, if I need to put 2 back in the house, you know how we have to take a triplet out of the house if we're taking the cube root? So if I'm putting 2 back in, I have to put it back in with its other 2 counterparts. So if I put 2 back under the house, I already have cube root of 5, right? And I'm going to put 2 cubed back underneath there. So I'm putting in 2 times 2 times 2 back under there, okay? And that would be 5 times 8, right? So I'd have the cube root of 5 times 8, which is the cube root of 40. Okay, a couple different ways to look at that, but certainly if it's a multiple choice, you can just plug in all the numbers that are here and see which one works. Okay, identify each expression that is in simplest radical form. So I need to make sure I don't have any negatives inside of cube roots, and I need to make sure that there aren't any perfect squares that are factors underneath. So 5xy to the fifth, I don't really care what's on the outside, right? I want to know what's under the radical. 7 and z, that is a fully simplified, right? I can't do anything more with 7 and z. Square root of 50 I know is the same as square root of 25 times 2. So I know that's not simplified all the way because it would be 5 roots of 2. Square root of 20, x to the 10, y to the fifth. All over the place I've got things, right? This is 4 times 5, so there's a perfect square in there. Anything with an even exponent is a perfect square, and y to the fifth would be y to the fourth times y to the 1. That's not all the way simplified at all. Square root of y, though, totally simplified. Nothing else you can do. Square root of the x to the 5th, not simplified, because of course that equals the square root of x to the 4th times x, right? So I could pull that x to the 4th out, and it would be x squared times the square root of x. So those are the two simplified all the way. All right, when x is greater than 0, which expression is equivalent to this guy? Well, I'm going to go ahead and just simplify. That's going to be, in my mind, 4 times 3, because I have a perfect square there, times x to the 8th times x, and so I'll pull that out, and I get 2x to the 4th times the square root of 3x. Oops, sorry. Okay, and so 2x to the 4th, 2x to the 4th, that's the only one that's there. All right, last little bit here. I'm actually going to do in a different video just because I'm about to have students walking in. So thanks for watching.